join me in welcoming our next speaker, the CEO of Bosch Sensortec, Stefan Finkbeiner.
So thank you very much, and I'm looking forward to have an exciting 15 minutes with you on what I want to present. The title is "The Sensing Robot is Here." Why we make a question mark behind? Maybe there are different expressions on your side or expectations on that side. If you go here on the BCV here, you have different kinds of robots you see there. My background, I'm a sensor guy. I'm making MEMS sensors. Bosch Sensortec is doing sensors for smartphones, and that means we are the guys who like high volumes in sensors. And this is what we need to refinance our topics. And if we talk about the robot is here, we of course have a vision of this, let's say, humanoid robot. So robots all everywhere, a lot of sensors in, and we will see if the question mark should be there or if it should not be there. But at least what I can say, there is a lot of excitement and movement going on this story. But why is it important to have a sensing robot? If you talk about a robot who should do everything, hopefully it works with the clip. So if you have no sensing robot, may go down this path. Yes, you can grip, you can safely grip this. But if you want to have a humanoid robot working under different conditions, not only in an industry environment, then you have to be able to detect also what you have to grip and to be very sensitive on how you make your grips happen on this topic. And this is why I think we still have a lot of work from these mechanical robots. We heard there is embedded AI necessary, definitively. But I think even the AI guys figured out AI is not that powerful if you have no sensors. And that's my message, of course, is you need a lot of sensors in these robots, and they have to solve fundamental solutions or challenges in, for example, this humanoid world where you have changing environments to be handled. And I think this is something, of course, a sensor company is more than willing to tackle and also to go into solving these kind of problems. If we talk about, for example, humanoid, and you say you have a human body, there are a lot of sensors around just to make somebody walk or maybe touch and be sensitive on these topics. And there are different numbers you can talk about, but to make really a human body work, more on the tactile phase, let's not talk about the skin and these topics, it's millions of sensors. Let's not discuss if it's 1 million or 10 or whatever, but it's a lot of sensors to make somebody walk around, to feel around, to make sure that you are not really touching hot surfaces, etc., etc. And maybe not all of these challenges. You also have to fulfill with a humanoid robot, quite some. And this is what I want to elaborate with you right now. How can we contribute to making these humanoid robots really reality and make it scalable in maybe also a household and not only in industry environment where you have relatively good defined situations, not if you want to put it on every workplace as we heard it, but at least if you want to put it on a very defined workplace. And we want to go beyond this. And why is this an important topic? You figure if you have a human being, this is now a mechanical topic, you can recover, but think about paraplegic people or some people who have neuromorphic topics. We know if you have no sensing, no acting, no signals around, it's a little bit difficult to manage your life. And that's why we have to transfer these sensors, at least quite a significant amount of them, also to humanoid if we want to make them walk around under all circumstances and have a safe operations of these topics. How does a sensor company like Bosch Sensortec tackle this topic? Of course, you cannot develop everything from scratch. And we benefit that we as Bosch Sensortec have already a broad portfolio and a significant amount of applications which we can start with and then adapt all these experiences and the sensors to a robot world and in the end also to a humanoid robot world. So this is more or less the portfolio of Bosch Sensortec which we have currently. We have, for example, sensors for gaming and toys. a lot of inertial sensors, accelerometers, gyroscopes, pressure sensors, gas sensors, quite a significant amount of topics. So these sensors are already around in different applications as you see it here. I don't think that we have to read them all for you, but messages for these applications, we have the sensors. They are small, they do not lose a lot of power, and they have already proven also to work around the body of human beings. For example, in watches, in hearing helps you have in your ears, and they are proven in all these applications. And that's the fundament right now to say, hey, maybe we can use these sensors, maybe start with this vacuum cleaner you see up there, where we already are in a kind of robot, and take this as a seed and then develop the sensors. It's not only about developing the sensors, it's also developing the ecosystems. You need integrators, you help you to do so. You have to define interfaces, and you probably and very likely need embedded AI interacting also with the sensors to make such a complex system happen. And that's what we have to tackle step by step based on the experiences we already have out of our current portfolio. How I see the world right now, if we talk about robots, yes, we have the vacuum cleaners, we have the lawnmowers already where you have sensors in. That's a given right now, it's still developing. But we are now on the way, I would say, to these cobots, not only the static robots, but also the cobots. And that's probably the next steps where I can get a lot of experience right now to finally, hopefully, scale on the humanoid side. So that means my expectation is until we really scale the volumes of humanoid, we still need some years. Maybe it's 5, maybe it's a little bit more until really the volumes come up, but what we see is right now that this ecosystem and the definition of the sensors, the embodied AI, and the architecture of these humanoid robots is happening now. We are working with all these companies, we have heard some of them, to figure out how do we have to set up sensors, how do we have to set up modules, which problems do we have to solve, what are the interfaces, what is the power supply situation, etc. And this is happening right now, even if the scaling may be a little bit later. But now it's the time to work on these humanoid robots, on the hardware and on the software side. And this is what we are doing. And how are we tackling these topics right now? If we look at humanoid robots, there are, I think, 2 big challenges. First of them is these robots have to really maneuver, have to walk in a more or less well-defined environment. And that's, I think, would say already a big challenge. Even if it's not that predictable in a very homogeneous and repetitive environment, you have to prepare not only for the operations, but also for some, let's say, challenges or traps which are moving forward. And this means, of course, that these humanoid robots need a significant amount of, for example, inertial sensors. So you have inertial measurement units in the head of these robots, you have them in the chest of the robots, and you have them in the leg of these robots. Why? If you want to keep a humanoid robot upright, you have to control all these movements. And this is a sensing solution which you need a lot of sensors, MEMS sensors, so silicon-based microstructured sensors, and they are already in. We see already that our sensors are used to train these robots, and that we also develop all the future requirements for all these applications and make them move around. And sometimes it's also pressure sensors, if you know which floor these are, and these are sensors which we know out of smartphones, right? There you have the I'm using. We know them out of watches. There you have pressure sensors in, which are able to detect floors or even steps. And this is what we now adapt and support to help these robots move around and maybe also prepare for some unpredictable situation to recover them and keep them upright now. That's a key requirement which is right now happening. If you need feet to walk around, situation much more challenging if you have a platform which rolls around, but I think we're able to make this happen. And you have already seen some of the demos the last months, where you see the progress of the last 12 months on how they move and how they can really handle situations right now. That's one of the big progresses. The second topic is, of course, also navigation. How do these robots know where to go? How do they see where they are right now? How do you steer them if they have to go from A and B? And that's, of course, a navigation problem. Very often, it's also a combination of sensors we do, so MEMS-based sensors as we have them here. It's also IMUs, it's also maybe magnetic sensors, pressure sensors, and maybe in interaction also with video sensors, with camera sensors, what we have to do. So it's not only that you can, as a sensor supplier, rely on you are working in your domain. You have to interact with all these our sensors, and you have to act with the integration and the evaluation of the signals in this world. And that means you have to go also in cooperations with partners, maybe companies with an AI accelerator, maybe the other sensor suppliers, and create a solution combined out of different ecosystems, out of different sensors right now to make this happen. That's, of course, also a lot of data, a lot of data fusion you have to handle with. And it's not that one sensor company can do this alone. Therefore, also we talk about an ecosystem which we have to support. We have to build relationships and interaction cooperations with our sensor companies, camera sensor manufacturers, for example, and also work on the sensor, we call it sensor fusion side, also aggregate our sensor signals digitally to make them also feasible and easy to handle for some of our customers or the integrators which use our sensors. And that's the second example I have right now. It's the navigation. And let's come to the third use case, which I think is the most challenging one. It's the strawberry season which we have seen before. If you want to make a hand able to handle different situations, not only handle, let's say, screws or steel, which is probably not the most sensitive topic with respect to controlling the force of a hand, you have to be able to adapt it to a specific situation, especially if you want to bring them maybe in a household in the end. You have to know what you are grabbing and then decide also on the force, maybe on the surface, maybe on the weight, etc., and the criticality of the mechanical fragility of a product. And that's a key topic to handle. And that means, for example, in a hand, you have, besides this challenge that you have to control the movement of the hand, especially this requirement of tactile sensing. And if we talk about tactile sensing, of course, it's really detecting the force you put with the finger on an object. That's one topic. Another topic is, for example, slippage detection. How do I know if I grab an object? Is it also safe, or what should I do? That's the second topic. And the third topic, which we have to cover with sensors in a hand, is that we also have to make sure that these robots are also very fast, because currently they are very slow. If they grab something, observe them, they are going in a safe distance, and then they are moving very slow to the object. So how can you also better control getting faster to the objects? And these are key topics which you have to do in a hand. The challenge of the hand is that typically if a hand grabs, your camera maybe in the head of the robot does not see anything about what happens. And that's why tactile sensing is a key solution. And we have in our booth a solution where we integrated the pressure sensor into the tip of a finger and made it sensitive to stress so that you get a feedback loop if you grab an object, for example, right now. You can look at this, and that's something we are working on. And of course, it's controlling the movements of a hand. IMU are important, controlling the force or the pressure on a hand, and that's what we have to solve. And if you dig into this topic, which I will do the last minute, you see that this is a quite resource and sensor intense task. If you look at these sensors which you need to control the movement of a hand, I think every ankle needs a sensor which controls this, and also on the fingertips right now, you may have around 100 sensors only for tactile sensing around a hand. I've seen demos, one hand, 35 sensors a few months ago, and then it's going down, of course, some other sensors, not going in all the details, but it's about control, the movement of a hand, and it's about tactile sensing. So how do you grip an object, which is a key topic, but easily you can have more than 100 sensors in a hand. And that's a challenge, and of course that's something we like as sensor manufacturers, because that's of course scales and volume. That's one topic, and the other thing I want to mention, there are people who say that a hand of a robot is a disposable. That's of course also something which scales the volumes up. But if it wears out, maybe a hand is a topic which you have to be able to replace. It's an ecosystem in itself, which you have to be able to handle, and you have to make it also an ecosystem on this topic. And if you have this amount of sensors in a hand, I think you need AI, you need embodied AI. My vision is we will have a local AI hub only for the hand. There is some AI accelerator on the hand, managing the grip and managing the movement of a hand, while local AI accelerators and softwares on networks to be able to handle this with speed and avoid that you have to put all the signals back to the main processor on the chest right now. And so for me, the vision is that a sensor supplier will not end up as a sensor supplier only, but we are more than willing to also interact on the integration of the signals. We call it sensor fusion, and maybe in providing with partners together a solution for this embodied AI on the hand specifically. And that's, I think, the task which we have to create better solutions for the future. And if we do so, I think we can also handle strawberries in future. Thank you very much. My time is over. And you can visit at our booth and then have some discussions on tactile sensing. Thank you very much.
Bosch.